Okay, gentlemen, so we've had a few different types of problems that we've done so far uh, in what we call stoichiometry, which is kind of applying math to a chemical equation. We started with, well, actually, let me go up here. We started with balancing equations. And we know that balancing equations is really important if we want to use some of the math that we've been using because it provides a uh, what we call the mole to mole ratio or mole ratio. So that's really important. We also know that the periodic table provides a ratio called the molar mass ratio that kind of relates how many moles are in a gram of a certain, or I'm sorry, how many grams are in a certain mole of a substance. So this one is always mole on the top and mole on the bottom. And the molar mass, you can either write it as grams per mole of a certain element or compound, or moles over grams. So these, and obviously there'd be like a number right here and right here. I'm putting like circles here to kind of represent, there'd be numbers there. The numbers in this ratio come from the balanced equation. The numbers for these ones come from the molar mass on the periodic table. So we've used all these things in a couple types of problems. We've used them on problems where we want to go from a mole of one substance to a mole of another substance. So mole to mole problems. And those are typically one step in the bridge method. We've done problems where we start with the amount of moles and we go to grams, or we start with the amount of grams of a product or a reactant and we end up with moles. Actually, I should probably draw this. This one's like this. Oops. Well, there we go. So these bad boys are two-step problems, and they're similar to the ones that we just worked on, the ones that were on the previous assignment. The last type of problem that we'll work on are gram to gram conversion. So if we start with grams of a product or reactant and we want to figure out how many grams of something else in the reaction that we would have, these are actually three-steppers. So although they kind of might look a little or sound a little intimidating because they're more than the previous amount of previous steps we've had, they're actually the same type of rules. So all of these things, we always use the same rules and the same method too, the bridge method. Okay, so don't be concerned about this too much. So I'm going to go ahead and show you how to do two gram to gram problems, and then you'll be on your way to trying the WebAssign and also trying some of these problems tomorrow. All right, so here's the first gram to gram problem that we're going to work on. And it's asked us to calculate the mass of AgCl. So we know that mass is measured in grams. So it's asking how many grams of AgCl, which is right here. So we're asking how many grams can be prepared from 200 grams of AlCl3. So this is a reactant. 200 grams of this produces how many grams of this. So it's kind of nice because it's already balanced. You can see the molar ratio, 3 to 1 to 3 to 1. The mole ratio is right there. And now what we got to do is the bridge method. So I kind of like to start with what I'm given with these kind of problems. Also, when you realize that you're going from grams to grams, you know that it's going to be a three-step problem. So I like to kind of write this as well, just to remind myself. So let's go ahead and write down what we're given. So we're given 200 grams of AgCl. AgCl3. Oh, sorry, we did that wrong. All right, and then I like to use the multiplication way of setting up my units. You know, Mr. Gamboa likes to do the crazy like box method or something. How crazy is that? He's nuts. So, all right, so I'm gonna set mine up like this, and I know it's a 3-stepper, so I'm actually gonna write in my other 3 steps here. And if you're a Mr. Gamboa fan, go ahead and write 3 boxes or whatever you want to do. So one thing I know is that I want to end up in grams of AgCl in the end. So I want to put that over here. I'll put grams of AgCl at the end. That's what I want to end up with. I know that I started with grams of AlCl3. So that's got to go down here because it's got to cancel out with kind of this diagonal unit over here. So what I gotta do right now is I gotta set up my units so they all cancel out. Now, whenever I have grams in a unit conversion, I always want to make sure that I use the molar mass. So whenever we have grams, we know that this is a molar mass ratio that I want in this one right here. So we always use grams with molar mass. The term mass means grams, is measured in grams. So I can put like 1 mole up here, or I'm just gonna put the number, just gonna put mole up here of Ag or AlCl3. So I know this is gonna be a molar mass because there is a gram in there, and I have to put moles on the top because whenever we use the periodic table, we always say 1 mole of this stuff is how many grams of that stuff. So I kind of know my units are gonna be like that. So I also know that over here, so this one also has grams, so this is also going to be a molar mass ratio. So grams of AgCl, I'm going to have to put moles of AgCl on the bottom. So I'm kind of just like filling out some of the blanks here with my units. What I haven't figured out, though, is what the middle one's going to be. What the middle units are going to be, the one in this step right here. So what I do know is that I can actually make moles of AlCl3 opposite. So AlCl3 is going to be diagonal to moles of AlCl3, and those will cancel out. So I want that to be there. Something else I might notice is that moles of AgCl is down here, and that should probably be diagonal to what's on top, so that the way those can cancel out. So just by kind of using process of elimination, I figure out all my units already. And I know that this is actually the mole ratio, this guy right here. We get that from the balanced equation. Okay. So now it's pretty easy. All we need to do is to put in the numbers. So the easiest one is the one for the balanced equation, this one right here. So I know that, let's see here, moles of AgCl. I know that 3 is going to go on top, and then AlCl3, it's a 1, right? So 1 and 3, that's our mole ratio from our balanced equation. And I also know that I can put a 1 here because we always put a 1 in with molar masses. And I just have to now put in the molar masses for AlCl3 and AgCl. And I can get those from the periodic table. Okay, here are the molar masses for AlCl3, 133.3 grams for every 1 mole, and 143.3 grams of ACl for every 1 mole of AgCl. So now, guys, we have all 3 steps laid out. We used 2 molar masses and a mole ratio. And every single gram-to-gram problem, you're going to use a molar mass, a mole ratio, and then a different molar mass. Every single time. The pattern stays the same. So now what's left is we have to multiply through. First things first, our units cancel out. And we're left with the unit that we want, grams of AgCl. That's what we're looking for. So now we'll go ahead and put the numbers into our calculator. There we go. We multiplied through the reaction. Our unit was grams of AgCl. And we end up getting 645 grams of AgCl. So these problems don't look much different than before. There's just an extra step, right? Just an extra step right here in the end. And we always go grams to moles, moles to moles, and then moles to grams. So it's always kind of the same sort of pattern each time. The next problem I'm going to do a little bit quicker, and I'm not going to explain it as much. But so I'm going to pause the video, my video, erase, and get to the second question. All right, hyperspeed. Well, not that fast. You can always stop it and rewind if you need to. All right, so I want to find the mass of PBI. That's I2, so that's grams of PBI2 is what we're looking for by reacting 30 grams of Ki, potassium iodide. So we have 30 grams of this stuff. Our equation's already balanced for us. Woohoo! We don't have to do that. And we start our bridge method with what we're given, 30 grams of Ki. This is a gram to gram problem. Mass is measured in grams, and we start with grams and we want grams. So it's going to be a three-stepper. 1, 2, 3. Next, I'm going to set up my units. I know that grams of Ki's got to be down here because they have to cancel out. I also know that I want to end up with grams of PbI2. Now I just need to go in the middle. What do I need to do to get from grams of Ki to grams of PbI2? I know usually wherever there's a gram, there's going to be a mole. Moles of Ki. And down here, this is going to be moles of PbI2. These are both molar masses. For each of these, I'm going to have to look at the periodic table. And from there, I can kind of go one step further. I know that this one's got to be moles of Ki, so I can get rid of moles of Ki up here. And this one has to be moles of PbI2 because I'm trying to get rid of moles of PbI2 down here. So they're kind of diagonal and they work out that way. So now that I have, oh, also one other thing, this will be the mole ratio from the balanced equation. This guy right here is the mole ratio from the balanced equation. So now that I have all the units in, let's put our numbers in. The easy thing is the mole ratio from the balanced equation. I know that for every 1 mole of PBI, I have 2 moles of Ki. So those are my first two numbers. The other ones are molar masses. I'm going to go ahead and calculate those molar masses now with my periodic table. All right, so 461 is the molar mass of 1 lead and 2 iodines. And the molar mass of a potassium plus an iodine is 166. So 1 mole of that is that many grams of that for each one of those ratios. All right, so next thing I'm going to do is I'm going to write out the math and then put in my calculator. My units cancel out, and I'm left with grams of PbI2 as my final unit. And here are the numbers that I got to put in my calculator. There are my numbers, and don't forget your unit. Our final unit is grams of PbI2. And when I plug all that into my calculator, I get 41.66 grams of PbI2. If you got in your calculator, if you got somewhere around like 166 or something like that, that's because you didn't multiply 166 and 2 together on the denominator, or you could just divide twice by it. You need to put these in parentheses, this whole thing in parentheses, so that way you divide by both 166 times 2, divide by the product of those two. All right, guys, that's about it. If you have questions, please leave them on Google Classroom or at the very end of the lesson with a smiley face or a frowny face. And that's about it. Thanks, guys.